Hi, boys and girls. This is Mr. Woods. And today we're going to be working at lessons 8.3 and 8.5, or lesson 8, session 3, and lesson 8, session 5 in your Ready Classroom math book. It's the one with the kangaroos and the funky monster on the front. Okay, so our objectives: fluently break apart two-digit numbers into tens and ones as a place value strategy for addition and subtraction. Fluently determine when regrouping a 10 is necessary and carry out the regrouping to find a sum. Fluently determine when decomposing a 10 is necessary and carry out the decomposition to find a difference. Use addition to solve a subtraction problem. Use addition to check the solution to a subtraction problem. Okay, before we get started into the book, I want you to do a warm-up. So pull out a piece of paper and a pencil or a pen or something that you can write with. Okay, let's take a look at this. It says here, use base 10 blocks for each number. Regroup 110, regroup, and I'm going to talk about that as 10 ones. Okay, so if you have base 10 blocks, where you're sitting there, you have 1, 2, 3, you have at least 20 of them or something like that. You can use this method, or what I like doing is I think I was showing you, so if I have 48 here, I'm like, it says 3 tens, so wait a minute, so I have 1, 2, 3, but I have 4 tens over here. Well, wait a minute, 1, breaking it into ones, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I have 8 more ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, let's take a look at this real quick. I know that this is a 10 because if I hold up my hands, 5 and 5 make 10. So that's definitely a 10. So I have 1, 2, 3 tens, and then how many ones? Count them up. We know this is 10. We can count on from there. 11, 12, 13, 14, 15, 16, 17, 18. Oh, so I have 18 ones. What did you get for the second number here? Well, this is a 6 tens and 5 tens, so I have one more 10 and then 5 ones. So I did that? Yeah. And also notice that I kept my ones on the right and tens on the left. These are my place values. So my place value is ones, and then place value of tens. Place value of tens is on the left. Place value of ones is on the right. I would say left and right. Okay, now we're going to be opening up the book, or if you have the sheets in front of you, or you can go and I posted the PDF for this. You can look at that and then write down the problems on it on your notebook or a piece of paper. Here we go, page 199. Let's read through this. It says here, after school, 85 students go home. Some of the students go home on a bus, but 26 students do not go home on a bus. How many students go home on a bus? Well, I want you to do this, but first let's go through and remember how we circle or underline important information in a word problem? After school, 85 students go home. Some of the students go home on a bus. So this is known, and some go home on a bus, but 26 students do not go home on a bus. How many students go home on a bus? Well, I like this because we know that this is the whole. That's the whole. This is a part, which is unknown. And this is another part. Let's draw our number bond. I love the number bond because it helps me organize my numbers into a way to where it makes it so that it's easier for me to do other things, such as standard algorithm or number line or whatever else I need to do. So let's take a look here. Now, what I want to do whole. This is a part. I'll set this up partially for you. I want you to pause the video and go through and try to solve this problem on your own. Okay, welcome back. All right, boys and girls. So we're working on this here, and we're trying to determine it. But let's go through and let's try it with, let's say, some 10 rods. So we have a total of 85, right? So I'm going to say 1, 2, 3, 4, 5, 6, 7. But wait a minute, I was looking at this number here. Hold on, let's fill this out. 85 and 26. Because 85 minus 26 is equal to this number here. So I noticed that my smaller number has more ones in it than in the larger number. So I need to decompose a 10. So if I have 7 10s here, 1, 2, 3, 4, 5, 6, 7, I need to have one more 10 for that 8 10s here. So I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I have 5 more ones. 1, 2, 3, 4, 5. Just want to point out this here. This right here is still a 10. Because remember, 5 and 5 make 10. That's still a 10. So, and I know that 26 students do not go home in a bus. So what I'm going to do is I'm going to say, and that's going to be a subtraction problem. It says 26, 10, 20, 1, 2, 3, 4, 5, 6. All right. Now, what do I need to do to do this? Well, let's take away these 2 10s. So those 2 10s go away. I have 5 ones here. Those 5 ones go away. But wait, I have one more 1. That's why I needed to decompose that 10 into 10 ones. So what does that equal now? That equals, let's count up the 10s. 1, 2, 3, 4, 5. There's 5 10s. So I'm going to put 5 10s. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 59 is my answer. 59. Now, it says part of the standard is to verify the answer to a subtraction problem by using addition. How do you do that, Mr. Woods? Well, let's start off over here. Let's see here. So I have these 2 numbers. Do these 2 numbers add up to make 85? So 59 and 26. That's going to be that there. I want to draw my line to separate my place values. So I have my place values of 1 on the right and place values of 10s on the left. Remember, move your right arm and that's going to be your 1. Move your left arm and that's going to be your 10. Okay. Let's see here. We're going to do a partial sum. So 9 and 6. So if I take 1 away from that 6 and make that a 5, that's going to be a 10. Oh, so that's 10 and 5 make 15. I have 5 1s and 1 10. We've already used these numbers, so I'm going to just draw a line through it. I'm going to draw another line here. So how many 1s do we have? We have 5 1s. How many 10s do we have? 5 and 2 make 7, plus 1 more is 8. 85. That number matches there, so we're good to go. Way to go to verify your answer. All right. I'm going to go through this. I want you to work on it first, and then I'll come back and finish the problem. So let's read through this. It says here, there are 65 cherries in a bowl. Dan eats 12 cherries with his lunch. How many cherries are in the bowl now? It says here, use 2 different strategies to solve this problem. Show your work. Okay. And as you can see, I have an open number line here, so I'm probably going to be using an open number line to do this. I really like using open number lines. But let's read through this again. There are 65 cherries in a bowl. Okay, I'm going to circle that. Dan eats 12 cherries. Ooh. So if he's eating them, he's taking them away, so I'm going to put a minus sign there. With his lunch, how many are in the bowl now? Again, to just get these numbers straight in my mind, I like the number bond. Let's go ahead and work with that. So my whole, this is the whole right here. This is a part, and then this is another part right here. So I have, which is unknown. That's just an unknown part. So a whole is 65. And then 12. And remember how number bond works. 65 minus 12 is equal to this number. So we're trying to find that number. But I'm going to use this number, this open number line. So I put the larger number on the right side. So that's going to be 65. I know that I've eaten 12, or Dan ate 12 rather. So I can make this a 10, or I can try to get closer to 65 first. So do I have the same as or more ones on with the smaller number than over here? I'm sorry. Well, I don't have the same as, and I don't have more. So therefore, I'm looking at the 10. So let's take a look at the 10. I have one 10 here, and I have 6 10s here. How many 10s do I need to add to get as close to 6 here, or at 6? Right. 1 10 plus 5 10s is equal to 6 10s, and that'll give me 62. So 6 10s. So that's, I'm sorry, 5 10s. The answer is 6 10s right here plus 2 1s, so that's 62. And then I have to add another hop there to make 62 to 65. So hold up 2 fingers. We're going up to 5. How many do you have to bring back up? 3. So that's equals 53. So I'm going to add those two together. 50 plus 3 is equal to 53. I'm going to write down 53 right here. Another way is, this is a standard algorithm. So many times you might see 65 minus 12 equals something. Well, I want to show you over here is that I can say 65 minus 12 equals a number. Remember, right now while you're still practicing this, draw your line between your place values of 1s, place value of 10s, and let's solve this problem. So 5 minus 2. Hold up 5 fingers, take 2 away, you get 3. 6, same thing, 6 minus 1, you get 5. Boom, we got the same answer. So here's the answer, and there's the answer. 2 different ways, same exact answer. We're still on page 202. Again, we're still in lesson 8, session 3. Let's read through this problem. Look at how Kate solves a subtraction problem at the right. Is her answer correct? Explain how you can use addition to check her answer. Okay, so I have a clue here. This is something, it says here, when I added the 2 parts, the answer was not the whole. So, wait a minute, how do I do that? Again, number bond. Let's look at this. So this is the whole. That's a part, and that's a part. So right here for the whole, I can put 86. And then those parts, there's 58 and 38. Well, 86 minus 58, is that 38? Let's check. So I'm unsure with this here. So let's do the standard algorithm, 58 and 38. We're adding those together. see if we get 86, because remember, we took away that 58 there. So let's make sure we know where our place values are. These are the ones, these are the tens. So 8 and 8, that's a large double, but 8 and 8 make 16. So I have 16 is a 110 and 6 ones. I have 110 and 6 ones. Now, that's just a partial. I'm going to take this away because we've already used those numbers. I'm going to add I'm going to bring down my ones here. I'm going to add the tens now. 5 plus 3 is 8 plus 1, oh. So here, when I added the two parts, the answer was not the whole. There it was. I added those two parts, and we were 10 more. What do you think she did wrong? She probably didn't regroup over here. Okay, she was just thinking, so she didn't take that 110 away from here to make that'd be 7, that'd be 16. Okay, and then if that was 7 right here, because you borrowed that 10 ones, put it over here with this 6. So to make 16 minus 8 is 8, 7 minus 5, and that would be 2. So there you go. The answer is 28. So that is incorrect, and the answer is 28 over here. And that's how you can solve it and explain it. All right, we're still on page 202, lesson 8.3. Number 8. Sean has 14 fewer crayons than Keisha. Keisha has 64 crayons. How many crayons does Sean have? Is it A, 78, B, 60, C, 54, D, 50? Pause the video, and I want you to do this. The reason I asked you to pause the video before I reread the question and circled or underlined the important information, because I want you to learn how to do that on your own. But I'm going to go through and I'm going to show you this. So Sean has 14 fewer crayons, 14 fewer. Okay, that gives me a clue. It's 14 fewer. So I'm looking at probably a subtraction maybe. Then Keisha. Keisha has 64 crayons. So I'm going to circle that. She has 64. How many does Sean have? So we're trying to find out how many total. So it's definitely a subtraction problem. Draw the number bond. Let's fill it in with the numbers here. So the whole, this is the whole right here, is 64. Sean has 14 fewer. So 64 minus 14 is equal to what number? This is perfect use for the standard algorithm. 64 minus 14. I'm going to draw that line to separate my ones from my tens. So 4 minus 4. Hold up 4 fingers, take away 4, get 0. 6 tens minus 1 10 is 5 tens. 5 tens. And that's definitely going to be D. Now to validate this, you can go back and you can add 50 plus, so do it in reverse. 0 ones plus 4 ones is equal to 4. 5 ones plus 1 1 is equal to 6. I'm sorry, 5 tens plus 1 tens is equal to 6 tens. See, I make mistakes. I'm learning too. So we're at the area for in lesson 8.3 on page 203, where you're going to do the practice. I'm going to help set it up a little bit. So let's take a look at that real quick. Study the example showing one way to subtract 2-digit numbers, then solve problems 1 through 4. Example, 75 people are at a ball game. 28 of the people are adults. The rest are children. How many children are at the baseball game? Then it shows here 78.5 minus 28. Because this is a whole. This is a part. 28 are adults. It says the rest are children. How many children are at the baseball game? Again, you can draw a number bond. organize your numbers here. And let's see here. So 75 is the whole. 28 are adults. And it says how many children. This is the number of children right here. We can show this expression as 75 minus 28. Look at this, how it says count back. 75 minus 5. So we're making a 10. That's making a 10. It's because we're subtracting 5. 70 minus 20, because we have 28, right? It's 50. And then 50 minus 3 is 47. Again, 75 minus 5, 70, 20. Add these numbers up. What you have is 28. And so therefore, it's going to be 47. So 47 children are at the baseball game. Look at this and see how you can apply it for the next problem. It's on page 203, number 1. Dave scores 43 points in a game and Lily scores 28. How many more points does Dave score than Lily? Use an open number line to solve the problem to show your work. This is what an open number line means. It's just a line. You have arrows on each end. How would I set this up? Well, Dave scores 43 points. And Lily scores 28. How many more points does Dave score than Lily? So we'll find out so it's a difference or a subtraction problem. Largest number, 43. Down here is 28. Rather than counting backwards, I like counting forwards, so you may want to count forwards to find out what that number is. Number 2, which equations can you use to check if the subtraction equation is correct? Well, let's look at these numbers. Again, number bond. Just do that. When you see something like this, where it's looking for the fact families, let's see here. So 72 is the whole, minus 24, and then 48. So if we look at this, if you say 72 plus 24, 72 plus 24, wait, that doesn't make sense. So that's probably not it. 48, well, there's not two 48s. 48 plus 24 is 72. That looks close. 72 minus 48, 72 minus 48 is that 24. 24 plus 48 is 72. So just remember how you work the number bonds, and that will help you with these types of problems right here. Lesson 3, number 3. Show 2 different ways that you can use a number line to find 70 minus 56. Remember how I said I like going forward? Maybe this one could be going backwards. And then it says here on number 4, which of the 2 number line strategies you use to solve problem 3 do you like best? Explain. So which way do you like going? Forwards or backwards? That was on page 204. Okay, boys and girls, we're on lesson 8.5. And this is where we're going to be, we're really refining everything that we've learned in the last 3 lessons that we went over. So we did 8.1 and 8.2, and then 8.3. Now we're going to be looking at 8.5. Again, it's a word problem, so we want to be able to circle the information, the important information in this problem. So number 1, Delilah makes this model to solve a problem. What problems does she solve? Write an equation. I'll give you a moment here to do that. Go ahead and pause the video, then come back. Okay, welcome back. All right, so notice how the arrow is going backwards. Again, I don't like doing it backwards, but let's just do it backwards anyway. So 93 to 90, so I'm subtracting 3. That's going to be 3 right here. Let's see, 7 10s to 9 10s. That's going to be 2 10s, which is 20. Let's see here, and then 6 1s to another 10. That's going to give me 4. Okay. How would you add that? What would you do with this here? You'd add them all up. So 20 plus 3 is 23. Or we can, and then add 4 is 27. Or we can add these two one numbers. So 4 and 3 make 7. And then adding 2 tens, that's going to be equals 27. Those plus signs in here. So we're looking at 93 minus 27 equals 66. There you go. Let's move on. Still on page 209. Let's read the problem through. Farmer has 76 horses. There are 27 horses inside the barn. The rest are outside. How many horses are outside? Tell if you use the equation to solve the problem. I want you to pause the video and work on this yourself. I know you can do this. Okay. Welcome back. Let's read through this and circle or underline important information. A farmer has 76 horses. He has 76. Okay. There are 27 horses inside. The rest are outside. How many are outside? Okay, so this is definitely going to be a subtraction problem. But remember, when I was talking about for multiple things like this, you want to write out a number bond. So I'm going to do a quick number bond over here. And that'll help identify which problems or fact families that you can use. So I have 76, which is my whole. And then 27 is a part. So I can go out and I can find this one. This is unknown. But let's see here. 76 minus 27 is equal to something. Do I have 70? Oh, look at that. So that's a yes. 76 minus 27. Notice how I did that? 76 minus, if I'm going this way, I'm subtracting is equal to that. Let's try this. 27 plus something is equal. 27 plus something is equal to 76. Yes. 76 is equal to something plus 27. Yes. 76 plus 20. No. That's definitely a no. Because it doesn't work that way. We don't add this way. We add this way, go up, or we add this way and go up. But we can subtract 76 minus 27 is something, or 76 minus something is equal to 27. Okay, page 209 there. We have one more. Tim takes $75 to the store to buy some clothes. When he leaves the store, he has $19. How much does Tim spend at the store? I want you to take a moment, circle the important information, and then come back. Go ahead and pause the video. Okay, welcome back. So Tim takes $75 to the store. So that's important. Yes, that's what he takes to the store to buy some clothes. So he's going to buy something. That's telling me that he's spending money. I'm going to underline that. When he leaves the store, he has $19. So it's definitely a subtraction problem. How much does Tim spend at the store? Well, we can write it out. So 75 minus 19 equals something. Well, that's a little tough, but what I want to do is I'm going to draw a number line. And I have my whole here. That's where I'm going to put 75. And then 19. I'm going to find out how much money that he spent. So I can make a 10. I'm just going to do a little one hop and add 1. Make that 20. And then I have 2 10s and 7 10s. I have to add 5 10s to get to 70. That's 5 tens is 50. And then to go from 70 to 75, just count on 70, 71, 72, 73, 74, 75. That's going to be 5. Remember how I showed you to add these numbers up? So 1 1 plus 5 ones is 6 ones. So I can, I have 5 tens plus 6 ones. So 5 tens and 6 ones. $56. So my answer is A. Okay. All right, so this is an interesting problem because if I just a quick look at it, shows here there's part A. It's on page 210. Now you can see the whole problem, so you'll see that there's part A and part B. I had to split it up just because of space. So let's read through this real quickly. Ahmed and Jenna pick up cans. Yesterday, Ahmed picked up 18 more cans than Jenna. Ahmed picks up 47 cans. Can you figure this one out? Let's see here. Part A. How many cans did Jenna pick up? Show your work. So we're trying to find out the total number of what Jenna needs to pick, or how many cans that Jenna picked up. So Ahmed and Jenna pick up cans. So we know that they're picking up cans. Yesterday, Ahmed picked up 18 more cans than Jenna, and that he picked up 47 cans. So number bond just gets those numbers in your right perspective so you can understand it. So Ahmed picks up 47 total. Okay. We know he picked up 18 more than Jenna, so he has 18 plus what Jenna has, and this is what Jenna has. I'm just going to draw a J. That's Jenna for Jenna. So 47 minus 18 is equal to what Jenna did. Oh, 47 minus 18 equals Jenna. I'm just going to leave that blank. That's just this right here, this blank, this unknown. How would you do this? Well, let's go back to the tens here. So I have, and it looks like, so I have more ones here than here. That means I'm going to have to decompose a 10. So I have 4 tens, but I'm going to do 1, 2, 3 tens. I'm decomposing one of those tens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 7 more ones. 1, 2, 3, 4, 5, 6, 7 minus 110. It's right there, and 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. All right. Whew. Let's take a look at this again. This is a 10. There's 5 and 5 make, so we have that as a 10. So there's still 1, 2, 3, 4 tens there, and then I have the 7 ones. Okay, so 1, 2. There's 8 ones here, so I'm going to take away 3. Take away 1, 2, 3, and I'm taking away 5. And there's 1, 2, 3, 4. Oh, 2, 3, 4, and 5. Take away 110. Take away 110. So what do I have left? I'm gonna put the numbers down here. So I have 1, 2. Oh, wait a minute. Took away that 10. 1, 2. Right. So I'm gonna have 2 tens. And then count up how many ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. 29. Is that number 29? How do you verify? Let's just do that really quickly. I'm going to have 29 plus 18. Remember, I want to draw my line. We're going to do a partial sum. Figure this out. 9. Well, wait a minute. What's 8 and 8? You should know your 8s. So 8 and 8 make 16 plus 1 more. That's that double plus 1 is going to be 17, which means I have 1 10 and 7 ones. Already used those numbers. So how many 10s do I have? Oh, wait, bring down my ones. 2 10s plus 1 10 is 3 10s plus another 10 is 4 10s. So yes, that is correct. So Jenna picks up 29 cans. Now remember that number. Jenna picks up 29 cans. We're going to put it up here. Jenna picked up 29 cans. All right. Let's take a look at this word problem here. This is part B. It's on page 210. Today, Jenna picks up 51 cans. How many more cans does Jenna pick up today than yesterday? Show your work. So Jenna picks up 51 cans. This is today. How many more cans she pick up today than yesterday? Show your work. Okay, so if she picked up 29 and 51, there's different ways you can do it. I'm going to opt for the number line, because she picked up 51 today. It's a larger number. It goes off to the right. And she did 29 yesterday. Okay, do I make a 10? Sure, let's make a 10. Let's just do a one hop. I'll make it so that it's 30. That was just plus 1. So I have 3 10s and there's 5 10s. I need to add 2 10s, so which is equal to 20. And that gives me 50. 50 and 51, that's just going to be another 1. So I add all this together. That equals, so 1 and 1 make 2 1s. And then I have 2 10s, so 22. So Jenna picks up 22 more cans today than yesterday. Notice how we're writing this out. All right, so this is where it says here, show one of the strategies used in part A or part B in problem 4 with a model or quick drawing. This is up to you. What I want you to do is you can go over here and you can take a look at your models here, see how we're drawing things out. I want you to, this is your individual thing, this is just to make it so that you have a better understanding. Verify, validate, and use what you know works best.